You still remember? Now give us some time to try it by yourself, and then I'll explain to the class, okay? Alright, time's up. Now let's take a look at question 5 together. Warehouse A stores 9 tons of grain. Warehouse B stores 160 tons of grain. How many tons must be transported from warehouse B to A in order to make the grain in A 4 times that in B? Alright, how should you approach this question? Again, we draw model. That's right, Zizi. Now, Zizi can tell me. Draw models. We draw models from which condition? Multiple scenario. Yes. So 4 times that is a multiple relation. Now, Zizi again can you tell me between warehouse A and warehouse B, which warehouse should be drawn by us first? B. Why B? Yes, because B has less number of the tons of the grain. So let's see, for this warehouse B, let's say warehouse B has 1 unit, then warehouse A will have 4 units. Oops. Warehouse A will have 4 units. Right. Then what do we still know? This is scenario at what time? At last, after transferring the money, after transferring the grain. Alright. Then, how do we find out 1 unit this time? To see? You need to find out the difference or the sum, right? Now let's see. For this, can we find out the difference? We can't. How about the sum? Now, let's recall a very important information. When you are transferring some value from one person to another, will the sum of these 2 persons change? No! So that means before and after giving out the grains, will the sum of A and B change? No! What is the sum of A and B? The sum is the sum of these 2 values, which is 250. So the sum here is similarly 250. Then how do we find out 1 unit? Now to find it out, we can use 5 units equivalent to 250. So 1 unit will equal to 250 divided by 5, which is 50. Now 1 unit equals to 50. We shall find out how much grain will be in the gift to A. How should we find that out? So at last, B has 50, right? But what is this value at first? Christelle? Yes, B will have 160 at first. So how should I find out the value transferred between A and B? Christelle? Very good! We can use 160 minus the current value for B. So 160 minus the 50 will give us 110. So that is the value B to give to A. Alright? So that's all for this question. Now let's see in this question, this scenario somebody is giving value to another body, right? So we call this a value transfer problem. Alright, now let me write down in this summary here. In the value transfer, now the total is unchanged. So that is a very important information in this question, okay? So class, please pay attention. In value transfer, the total before and after always remains unchanged. So the total remains unchanged. Right, so that's all for this question. Now, why should I say this question is a kind of a series of problems? Because there are a lot of variations about value transfer. Now let's just interpret the key lies behind this value transfer, okay? So before that, let me give you some examples here. Think about this question. Let me give you some examples. let's say again there are two people, A, B, and Bess. Okay, so A and B. For this A and B, let's say in the first scenario, A has 6 number of candies and B has 16 number of candies. Alright, now we know that A transfers 2 candies to B. Alright, first of all, let's try to find out what is the difference in terms of a candy at first. Anybody has an idea? Bernice? The difference is over here, right? The difference over here is 16 minus 6, which is 10. So their difference at first equals to 16 minus 6 equals to 10. Now what if this A gives 2 candies to B? Now let's see, A will give, let's say, these 2 candies, give away to B. So B get another 2 candies over here. Now my question is, what is the new difference? Richard? To compare the new difference, okay, so this is 4 now. This is what A have now, this is what B have now. So the new difference is a line over here. What is this length, Bernice? This is 10, this is 2, this is 2. So 10 plus 2 times 2 equals to 14. So the difference at last equals to 14. Now, what can we observe over here? What is the change in terms of difference at first and at last? The change in difference equals to 14 minus 10 equals to 4. What is this 4 so special? Any idea? Now you observe that A give how many candies to B? Give 2 candies to B. Then the change in difference equals to 4. So that means what? If you're giving some candies to another person, not only will you lose these 2, but another person will gain another 2. If A at first is less than B, see A is already less than B. If A still need to give something to B, then the difference will enlarge. Enlarge how much? Enlarge twice of the value transferred. Okay? So thus, we can conclude that if somebody has less, somebody has more, the less person to give something to more person, then the change in the difference equals to twice the value transferred amount. So we can see that if less give to more, then this change okay, so let me change this. This change equals to twice the value transferred. Now this is the first scenario, right? And the first scenario, A has less than B and A still need to give something to B. But how about the second scenario over here? In the second scenario, let's say A has more than B. What will happen? Let's say A now has 10 number of the steps. Then for B will have, let's say, only 6. Alright? Now class new difference? What is the current difference here? Currently, their difference is between 10 and 6 over here. This is 10 minus 6 equals to 4. So the difference at first equals to 10 minus 6 equals to 4. Now, if I tell you this A, she will give some steps to B. A will give one step to B. So let's say A give up this one step to B over here. Now this becomes 1. Okay, let me change it. So this is 4. Now if A gives something to B, B receives this 1. What is the new difference, question? Now, this is what we have. Let me highlight it with a red chalk. This is what A have. So what is the new difference over here? The new difference. You see, in total this is 4, right? Now, how will find this value? But this use 4 minus these two values. These two values are 1. So 4 minus 1 times 2 should give us 2. So the difference at last equals to 4 minus 2 times 1 equals to 2. Then what is the change in terms of the difference? See? 4 minus 2. So the change in difference equals to 4 minus 2 equals to 2. Okay, so what can we tell for this value change? The difference change and the transfer value. The change difference is 2. The transfer value is 1. Now imagine this. At first, A has more than B, right? A has 4 more than B. Now A needs to transfer some value to B. So we can see that's the difference. With the difference enlarged or the difference shrink? Get smaller. Yes, the difference will get smaller. Now get smaller by how many? By smaller by, you see, not only B will now receive the transfer value, A will be decreased the transfer value. So actually, this difference has changed twice the transferred value. So again, we can see that the change in difference equals to twice the transfer amount. So difference change equals to twice the value transferred. Right, so that is the second scenario. Now, let's see another scenario here. Will this rule still hold? Let's see. In the third scenario, at first, A and B, they have the same amount of candies. Let's say A has 50, B again has 50. Now, A gives something to B. A gives, let's say, 5 to B, alright? So A give up 5 candies to B. B receives these 5 candies. At first, what is the difference? Difference at first is 0, right? So what is the difference at last? Now, this is what A have. And this is what B have now. How do we find out the new difference? It's the length of this line. What's the length of this line? Charlotte? 5 plus 5. So 5 plus 5 will give us 10. So the new difference becomes 10. Now again, the difference at first it's 0, right? Because they have the same amount of candies. Then the difference at last is what? Is 5 times 2 equals to 10. So what is the change difference? The difference change equals to 10 minus 0 equals to 10. Now what's the relationship between the change difference and the transfer value? At first they have the same amount. Now if A gives 5 to B, then A will lose 5 and B will gain 5. So the difference will enlarge to how much? To 10, to twice the transferred amount. So even in this case, the change in your difference equals to twice the transferred amount. Okay, now these are the 3 scenarios. Now let's take a look at the last scenario over here. Now you may wonder, in the fourth scenario, if let's say A has more than B again. So A has 10, then B has 6. What is the difference at first? The difference at first over here is 4. So this is 4 here. Right? So this is 4 and this is 6. Now let's imagine this A will give B 8 value. So let's find out the new difference. A will give B 8 values, right? So is this 4 enough? No. But at least it's 4 and then transfer to B. So B will get this 4 more. But that is not enough. A still give up how many? 4 more. Because A in total is to give up 8. So A now will give up another 4 over here. What's left is 2 over here. Alright, now this is again giving up 4 over here. 4. Now my question is, what is the new difference over here? The new difference is this amount. How do we compute this? Well, this 4 plus 4 plus 4, so 4 times 3 equals to 12. Now again, let me write down the difference at first. Equals to 10 minus 6 equals to 4. The difference at last equals to 4 times 3 equals to 12. So what is the change in terms of difference? Jason? 12 minus 4? Okay, now everybody please take note. There is a very important trick here. You see, at first A has more than B, right? The difference is 4. At last, will A still be more than B? No! This time A is less than B! Everybody please focus! So you see, at first A is more than B. Now not only will A not have 4 more than B, but this time A will have 12 less than B. So what is the change in the difference? 4 plus 12. So the change difference equals to 4 plus 12 equals to 16. Right, again, what is the relationship between the change difference and the transfer value? We transfer how much? Transfer 8 candies. So again, the change in difference equals to twice the transferred value. So we can conclude that in the value transfer problem, the change in the difference equals to twice the transfer amount. So difference change equals to twice transfer amount. Alright. Now if you understand this, how about let's try out question 6 by ourselves. Also, you can write down all these models next to question 6, okay? Alright, question 6. Let's see. How can we apply this formula in question 6? Hale has 3 times as much money as Susanna. After Susanna gives 20 to Hale, Hale has $110 more than Susanna. How much does Susanna have in the end? How should we approach this question? Yes, we draw models. Now, where is the multiple relationship? 3 times. So we start from Susanna. Susanna has 1 unit. And here we have 3 units. 1, 2, and 3. Alright. Then Susanna have give 20 to Hale. Hale has 110 more than Susanna. Let's see. Now in the normal way, in the usual way, we draw models to interpret this, right? So let's see, in the first method, this Susanna give 20 to Hale. And then Hale has 110 more than Susanna. So that means this value becomes $110. Then, how do we find out 1 unit this time? You see that 110 equals to 2 units and to extra 20, right? So how should we find out 2 units here? Charlotte? Yes, you need the first minus is 2 extra 20. So our 2 units are equivalent to 110 minus 2 times 20, which will give us 70. So 1 unit equals to this 70 divided by 2, which is $35. That is the value for 1 unit. Then we're going to find out how much does Susanna have in the end. In the end, this is what Susanna has. How do we find out this length over here? We know 1 is 35, so in total this is 35. Susanna give out 20, so Susanna have in the end, we have 35 minus $20 equals to $15 left. So that is the answer. This is the most common way to solve this type of question because we draw the models, right? Now let's see how can we apply the previous conclusion to solve this question. Now let's call this method 1. In method 2, how should we solve this? Okay, I'll write it here. In method 2, again we draw a model like this based on multiple relationship. So S has 1 unit, Hale has 3 units. Now we know that Susanna gives 20 to Hale, and Hale has 110 more than Susanna. If that is the case, at first Susanna has less than Hale, right? So this is a new difference, 110. Now, how can we get the old difference? Think about it, what is the change into the difference? The old difference should be 2 times 20 less than 110, right? So the old difference can be computed as is a new difference 110 minus 2 times 20, which will give us $70. So you don't need to draw this model. Just by this property, you can find out $70. And then similarly, 2 units equivalent to 70. 1 unit equals to 70 divided by 2, which is $35. And as in the end, we'll have 35 minus 20 equals to $15. And you'll get the same answer. Okay? So these are two methods to solve this question. During the exam, you can apply either of these two methods. That's totally okay. Okay? So that's all for question 6. Now let's take a look at question 7. Again, question 7 is a type of question we learned in lesson 4. In lesson 4, we use a normal method to solve it. We draw the models. So now, first of all, let's do a revision about how to draw models, and then we shall use this method to solve it, okay? Right, you can take a look at it first, and then I'll explain to you. Alright, time's up! Now, Cindy had 604 more stamps than Tom. After Cindy had given 102 stamps to Tom, Tom had 4 times as many stamps as Cindy. How many stamps did Tom have at first? Again, how should we approach this kind of question? Yes, we draw the models, but we draw models starting from which condition? Multiple. And Tom has 4 times as much as Cindy, so Cindy has less. Cindy has 1 unit, then Tom will have 4 units. Alright, then let's say Cindy has 604 more than Tom. This scenario at last. At last, Tom will have 4 times as much as Cindy. But what happens in the middle? Because the Cindy had given 902 to Tom. So at first, Cindy had some more than Tom. How many more? 604 stamps more than Tom. Now what happened? Cindy gave away 902 to Tom, right? So not only will this 604 given to Tom, but he will again give how much to Tom? What is this value? So 604 902 minus 604 will give us 298. So Cindy still again needs to give 298 more to Tom. So these two has been cancelled out. So Tom will receive another 298. Tom received another 298 to get this value. Okay? Now, how do we find out 1 unit this time? Again, we shall find out the difference over here, right? What is this new difference? You observe that this equals to 298, this is 604, this is 298. So the difference is 604 plus 2 times 298. And then you'll get 1,200. That is the new difference. And what else can we know? 3 units are equivalent to 100,200. So 1 unit equals to 1,200 divided by 3, which is 400. So 1 unit now is 400. How do we find out stamps Tom had at first? At first, this is what Tom had. Tom has 4 units, but this amount less than 4 units. So first of all, let's compute. Tom at first will have 4 900, that is this 4 units at last. Then Tom received 902 from this city, right? So you know, minus is 902, and then you get 798. That is the answer for this question. Now see, in this question, we draw models to interpret the process of the value transfer. We call this method 1. Now, how about for method 2? In method 2, similarly, we can draw a model like this. Okay, so let me draw a model over here. At last, city has 1 unit, and this Tom has 4 units. Alright, so at last they have this amount, right? Now we know that city has given 902 to Tom. So how do we find out the difference at last? To find out the difference at last, we need to know the difference at first and the change in difference, right? The difference at first is 604. Then what is the change in difference? A change in difference is twice the transfer value. That is 902. So 2 times 902 equals to 1,804. So the change in difference is 1,804. But at first, this city has only 604 more than Stina. So what does that mean? That means not only this time will city not have 604 more, but instead city will have some value less than this Tom. How many less? Is the new difference now is 1,804 minus your 604, which is 1,200 less than this Tom. And we know that the new difference now is 1,200. So similarly, we can write down 3 units are equal to 1,800. So 1 unit equals to 1,200 divided by 3, which is 400. So now 1 unit equals to 400. How many steps did Tom have at first? This is what Tom had at last. Tom received 902. So Tom at first will have 400 times 4, and then we minus what Tom received, 902. And you get the same answer, which is 798. Okay? So both of these two methods, they are workable. Either you can draw a model to interpret this, or you can use this formula. Difference change equals to twice the value. Just to keep in mind, if at first the difference is less than difference change, then that means your relationship will change. At first it has more, then if your change in difference is larger than the value of more, at last it will have less than Tom. Okay? So again, you can use this formula. Difference change equals to twice the transfer amount to solve this problem. Okay, that should be all for this question.